Did Makita really give us a completely new impact driver in the 40 volt series? We'll find out in just a moment. I'm Tim Johnson. You're watching Shop Tool Reviews. Now what we have in front of us is the new XGT impact driver. The XGT is their new 40 volt line of tools, and this is the GDT01, which is specifically their multi-mode impact driver, and it's got more features than your old calculator watch. But anyway, we'll dive into that in just a moment as well. Well, actually not, because we've already reviewed this, so we'll put a link to the review of this, but we wanted to see, is it much different than this guy here, which I think may be their first brushless model impact driver. Why is it still around the shop? Because I love it. There are 0 features on this other than a variable speed trigger. That's it. Brushless motor, 18 volt tool, and a variable speed trigger. That's how I like it. I know a lot of people like these different features and drive modes. I'm just not that kind of guy. I'm not stepping on this tool. That's not what I'm here to do, because again, I know others love that. What I am here to do is crack this open. Let's take a look. Did we get a completely new tool, or are there a lot of things that are the same and we just upped in electronics and voltage? Let's get to it. Recently, Makita came out with their new XGT platform of power tools, as you see here on the right. It's their 40 volt series. Now, used to their top end game was their LXT series, which was their 18 volt. Both of these are brushless tools, and both these are 1/4 inch impact drivers. Actually, this one's a couple of models old, so this is definitely not their newest model, even the 18 volt, but it is their brushless impact. I wanted to get an idea of what the difference were between these two. Now, this one is quite a bit more powerful, but it's not staggering like off the charts. But again, I think we've gone too far with impact drivers anyway, so that's not my point here. I do want to take an internal look to see, is there a lot of difference between these two tools? Or are we really looking at just kind of a voltage upgrade as far as the tool's concerned and as far as the upgrade's concerned? So we're going to take these apart, take a look at the impact mechanisms, also take a look at the brushless motors, do some weights, do some measurements, and see what we find. So let's first take a look on the surface of these tools. Over here on the left, we have the XGT01. So this is their impact driver, 18 volt, again, brushless version. And over here on the right, we have the GDT01, which is the newly released 40 volt impact driver that Makita just released. Again, both of these brushless. This one running on 18 volts, this one running on 40 volts. Now let's go ahead and get a weight on these, and we'll weigh these without the battery, because we know the 40 volt battery is it is going to weigh more. There's more cells in there. So the 18 volt tool without the battery is 2 pounds, 1.5 ounces. And the 40 volt tool is 2 pounds, 2.3 ounces. So this one weighs a little less than the 18 volt. So maybe we did some upgrades, as well as obviously we lightened some components. Now height wise on these two tools, I'm really not going to measure them, but you see they're pretty much the same. The new one is just a tad shorter than the old version, and with the battery it's going to be different depending on which batteries you're running. This is a 3 amp hour, this is a 2.5, but again, big voltage changes, and you could run slim packs on one and not on the other. So regardless, without the battery packs, we're really close in size. And then even straight on, again, pretty similar. We're not crazy about taking a measurement right now, because we're comparing these two just to kind of see the differences. I will say there's a lot more features on this one. I've always loved this tool, and that's why you see it's pretty beat up, because it gets used all the time. It is a very simple impact driver. Pull the trigger and it goes. Variable speed, brushless impact driver. There are no features other than a variable speed trigger, and I love it. Now let's get a different vantage point here and take these apart and see what we think. Okay, let's first take the 18 volt apart. We'll get things out of the way here, and we may fast forward through some of this just so you're not having to watch every screw taken out here. One thing I do like about Makita is they still use Phillips head screws. No guessing about what tools you need to take these apart. Okay, we've got the 18 volt apart. Now let's take care of the 40 volt. Again, looks like Phillips fasteners everywhere. Okay, pretty simple. By the way, make sure you cut that decal there on the top if you're trying to take yours apart. And by the way, you'll probably void your warranty if you're doing that. So just take that at your own risk. Okay, just a couple of obvious observations that I've noticed in just taking the shell apart here. Number one, we have a huge heat sink right here. Love to see that. Anytime we're getting rid of heat and we're dissipating that heat, I love to see that. That's helping electronics, that's helping comfort, ergonomics, you name it. If we can remove heat, get it out of the tool, that's always going to be huge. And we are definitely doing that because, like I said, that's a huge heat sink there. Obviously, that's where a lot of the electronics are residing. You see that like an epoxy pour. I don't know if that's correct or not, if it's an epoxy, but that's the idea here. It's basically a poured fluid that then hardens and protects all the electronics, but definitely on this side, as you see here, we have the same type of substance here sealing this, but we don't have the huge heat sink like we do here with the aluminum base that, again, with all those teeth there, are dissipating any of that heat that we may be generating in this tool, or at least in the electronics. And here's our control board that's just kind of looks like kind of a face, or just the push buttons for what we have right down here. So again, there's the underside of that heat dissipating block there. So doing a great job of, again, trying to eliminate as much of that heat as possible. And then we have, it looks like we have a 30 amp fuse right there as well. So it looks like that could be a line of protection for sure if we're overamping, that 30 amp fuse can blow and obviously be a quick fix for, I'm sure, their service center, but something that's not existing over here on this older 18 volt tool. And then something else that's obvious is on the front side, on the 18 volt, we had a nose cone that obviously came off, and inside that nose cone was right in here is our 1/4 inch anvil, and you see the two dogs on those anvils, or on that anvil, and then you see the dogs here on the weight mechanism that basically this turns around and around and hits these dogs. These dogs collide. That's what these things are called right here, dogs. And then once it hits those two anvil ears, then it overcomes this spring here and jumps over and then hits once again on these dogs. This is the planetary gears. There's only 2 gears here on this planetary, and those 2 gears ride in this ring gear right here. So basically the motor spins this, or this is attached to the motor, kind of a pinion gear if you will, and that spins these 2 planetaries, which then ride around that ring gear. That drastically reduces, well, I shouldn't say drastically, but that reduces the amount of RPMs that this is spinning. So that motor may be spinning 10,000 RPMs, and this anvil is only spinning, say, 2,000 RPMs. It really depends on the number of teeth on the gears and so forth. We could do that calculation, but not for this video. So anyway, that's pretty obvious, you know, on this tool, that we can see that was all housed in that nose cone. Whereas on the 40 volt, we don't see that. That's hidden behind this case here, and looks like something we'll have to pull out as one unit and then take that apart. We've seen this on other tools as well. But then we have the brushless motor here. That's something I wanted to get to. That's what I wanted to kind of measure and say, are we dealing with a bigger brushless motor, or are we just feeding it more voltage, more current to drive the motor harder and faster? And I think I already see my answer, but let's get our dial calipers out and see here. And by the way, don't trust my figures to be perfect, but we'll get an idea. So looking at 1.7 inch diameter of the brushless motor. Yeah. So 1 3/4, let's call it 1 3/4 inches for the brushless motor on the 18 volt. Wow, that is identical. Literally, I mean, if they're within 1,000th anyway. So they're very close in size and diameter. Now thickness, I don't know how I'm going to really be able to get a thickness here. Let's call that 0.68. And looks like the old one may be a little thicker, but again, I'm measuring the plastic housing and everything, so I don't get a good reading on that. But as far as the diameter of the brushless motor, it's looking very, very similar. Interesting. Now let's see if we can get this one off without causing too much havoc. Okay, so then we see that pinion gear that we saw on the other one that was actually coming through the tool. That's that same type of pinion gear coming through the brushless motor. Like this will pop off, so the plastic housing here will pop off. So it did take a little convincing, and I had to put it in the vise and then use a big crescent wrench. And by the way, it is reverse thread, so this piece here, righty-tighty, loosens it. So then in here, this is the first time, by the way, should be our planetaries as well as our anvil and all that mechanism. Have a bearing on that backside. Like to see that. Okay. And, oh wow, so our ring gear comes out with it. And here, we've got an upgraded tool, delivers more power, so therefore really needs to be able to support that power better. And we've got a 3-gear planetary versus the 2-gear planetary that we had on the 18 volt. So I like to see that, so definitely an upgrade in the planetary gears. Now as far as size, it looks like those gears are a little bit bigger. Again, we could count teeth if we wanted to. I'm not getting that in depth right this second. But the ring gear comes off with this, and then we have our planetaries, and then we have our anvil here. Well, our anvil is actually in there, and then we have our counterweight that's driving this. Now, one thing I am curious about, well, actually looks like a larger bearing on the old one. Let's keep that off for right this second. And so here's the 18 volt. Here is the 40 volt. And it looks like our counterweight or our impact weight is larger on the 18 volt, but let's get a weight on it. And let's weigh these in grams. So here's our 18 volt, 240, and here's our 40 volt. Wow. I would say that's pretty much the same. What do you think? 240 versus 240. And just so you'll see, 480. So, identical weights on these. This is getting really interesting. This is almost telling me that in the model, since this impact driver has been made, that there's not a lot changed on the mechanical side of things, other than we get a 3-gear planetary and a different size how they've handled this. But as far as the weight driving against the dogs, we still get the same thing. In fact, we still got the same size diameter, same size dogs. So again, just different planetaries, but the same amount of weight driving these, driving this against the anvil. But again, we have, I believe, larger size teeth here, or larger size planetary gears, but they could be identical. Well, they matched up pretty well. So literally could be just that we have a 3-gear planetary versus a 2-gear planetary. And 1, 2, 3, 4, 5, 6, 7 teeth on the pinion gear. And 1, 2, 3, 4, yeah, 7 teeth on that as well. Let's see. Yeah, I don't know that I want to dig. No, there we go. Very remarkably the same. I don't see any of the same number markings on them, but they very much measure the same, and definitely the mechanicals are looking pretty much identical. All right, let's get this back together. I think that O-ring goes in first, and then our ring gear. And again, we're going to go reverse thread. Okay, let me first say, well, I guess not first because I would have said that long ago. Anyway, I'm not an electronics engineer. I'm not even an electronics professional. However, I can use my senses to kind of look at things and mechanically figure out, do we have a different tool or not? Electronics-wise, yes, definitely there's some upgrades in electronics and there's definitely some differences in electronics. That's obvious. We're running a 40-volt battery now. We can't just slap a 40-volt battery onto an 18-volt tool and it worked just fine. You're probably going to overheat some things, maybe even blow some fuses or circuit boards, whatever. Again, I'm not going to get that deep. But as far as the internal mechanics of this, as you saw, I don't know that we have a different tool. I think the anvil's the same size as far as the weight driving it. I think the actual 1/4-inch anvil is a little bit different just because of the snub nose effect on it. But otherwise, sizes are pretty identical. I do like the 3-gear planetary gear. I think that's going to support the more power that we're driving on this tool. But as far as that goes, it looks like the brushless motor's relatively the same size and maybe even the same motor. And it looks like that, again, the drive side of things are pretty much identical other than that 3-gear planetary gear. Do I think that's a bad thing? No. I think we've gone way overboard in impact drivers on what we're delivering on power. I think Makita does a good job of engineering tools that just, what does it need to accomplish the job? Because even releasing a brand new 40-volt tool, they're not the king of torque, if you will, in that impact driver mode. There are other impact drivers that deliver more power. But do you need that on a 1/4-inch bit? No, you don't. If you need more than that, then you need to be going to an impact wrench. So anyway, I will save that argument for later. So I guess my point is on the 40-volt impact driver, the GDT01 doesn't look a lot different than the XGT08. I forgot the model number to the old impact driver. Anyway, you can see this has been around the shop a while and it still works great. And by the way, they still work great also even after I took them apart. Forward, reverse, all the modes, I checked them out. They work. Even the LEDs. I was concerned about that. They kind of snake around this tool and around the front snout. Anyway, so hey, great tools here from Makita. Just wanted to show you what was different on the inside and out. Let us know what you think. Also, would you keep track of us on Instagram, Facebook, and Twitter? And if you don't mind, would you hit that like and subscribe button? But only if you liked our video. If you hated our video, give us a thumbs down, but would you let us know in the comments why? Have a great day and keep smiling.